Hey, this video is to show you guys how to do the Archimedes Gizmo if you were either absent for it or you just need a quick review. So if you go into our Google Classroom and you open up the Archimedes Gizmo assignment, you can read the story of Archimedes in comic book format if you would like to. And then your assignment, this Google Doc, should be off to the side here with your name on it. You will need to log into Gizmo. You do it through your class apps. And they changed what it looks like this year. It's Explore Learning instead of Gizmo. When you click into Explore Learning, it might pop up something that says, like, we need your teacher's username. Don't put anything in. There should be a button underneath it that says, I'm new to Explore Learning. You can click on that. When you click on that and it takes you into Explore Learning in Gizmo, you'll probably have a page with a bunch of blue squares for your classes. If you go up to My Classes and choose Science 7th, it'll take you to a page that has this Archimedes principle thing on here. If you launch that, this is where we're doing our virtual lab stuff. Okay, so you need that tab open. You also need your document open, which is, again, going to have your name on it over here on Google Classroom. All right, within the Archimedes Gizmo. So we are learning about density. I'll do the prior knowledge questions with you. Why does a pebble sink in water, even though it's very, very small? It's because it is more dense than water. Okay. Similarly, a motorboat is a lot heavier than a pebble, but why does that float? It's because of all that empty space within the boat, the hollowed out areas inside. It makes the boat less dense than water. All right. In your Gizmo, a couple of things. So when they refer to the boat in your instructions, they're talking about this little cylinder here. You can change the dimensions of your boat over here. With length is like front to back, so you can't really see it in this two-dimensional image. Liquid density is how dense this is. 1.0 grams per milliliter is the density of water. So unless your instructions tell you to change it, leave this liquid density at 1.0 for water. The show data button, if you click on that, that'll show you a lot of the numbers that you're going to need for the Gizmo. And then magnify waterline just lets you see the waterline a little better. So the first step says, check that the width, length, and height of the boat are set to 5. Drag one of the green cubes into the rectangular boat. What happens? All right, it causes the boat to sink down a little bit. Add cubes until the boat sinks. What mass of the cubes causes the boat to sink? So if you look over here, this tells you how much of a mass you've put into the boat. The graduated cylinder number over here, this is how much liquid has been displaced into your graduated cylinder over here. So when our boat sunk down because of a 50-gram weight in the boat, it caused 50 milliliters to be displaced into here. It also caused the boat to sink down about 2 inches. That comes in your later questions if you need to see how far down the boat sank and you can't see this very well. That's what that magnify waterline does. You can see that it sunk down about 2 inches. Actually, I think this is measuring in centimeters, so 2 centimeters. If we add more cubes, 3 cubes causes the boat to sink, and it says that that had a mass of 150 grams. Okay. Moving on down, you can work through those on your own by reading the directions. Down here, it says choose a new set of boat dimensions, add cubes to the boat, and record the volume of the displaced liquid. If the boat sinks, try a larger set of dimensions. So you get to play around with whatever you want. I'm going to make mine just totally random, 8, 6, 8. So our width is 8, length is 6, height is 8. Let's put a couple cubes in the boat. We put 2 cubes. Our boat mass is 100 grams. It asks you what the volume of displaced liquid is. So we can see that in here. In the graduated cylinder, we displaced 100 milliliters. And then the mass of the displaced liquid, you might be a little lost here because that doesn't give you that number anywhere in here. Well, if you read on in the directions, it says density is equal to mass per unit volume. To calculate density, divide the object's mass by its volume. If the liquid's density is 1 gram per milliliter, which it is over here because that's the density of water, the mass in grams is equal to the volume in milliliters. So these numbers should be the same. So whatever you set your boat dimensions to for the rest of these answers, your boat mass, your volume, and your mass of liquid should all be the same number across, as long as your boat doesn't sink. If your boat sinks, then that messes with all your numbers. So make sure that you don't add so much mass that it causes the boat to sink. All right, continuing on down here. This says turn on magnify waterline. Experiment with different sets of boat dimensions and loads. In the table, record each boat's width, length, mass, the depth to which it sinks, the volume of the displaced liquid. Leave the last column blank, and then we'll come back to it. So let's do that for one of them. All right, I'm going to change this. So I've got 3 for width, 6 for length, 4 for height. It actually doesn't want us to record our height, so that's fine. Boat mass, let's put 1 cube in. So I have a boat mass of 50 grams. Then it wants us to give the sinking depth. I can't quite see that, so I'm going to turn on magnify waterline. It looks like just above 2 3/4, so like 2.75. I'm going to say 2.8. 2.8 centimeters. Volume of displaced water, 50 milliliters in our graduated cylinder. Okay, and then volume underwater. It said come back to it, but we come back to it in step 2. Label the last column in your table volume underwater. To calculate the volume of the boat that is underwater, multiply the width, length, and depth of the boat. Record the underwater volume of each boat. All right, so I'm going to do my math. I'm going to multiply. Here, I'll do a calculator on the screen. 3 times 6 times my 2.8 centimeters that it sunk down. It's about 50. You can just round to the nearest whole number. 50 milliliters. When you get down to analyze, it says what's the relationship between the boat's mass, the volume of the displaced water, and the volume of the boat that's underwater. If you're doing your math correctly and your boat didn't sink, then this number, and this number should all be the same. Okay, you guys can fill in the rest of those. Continuing on down, number 9, measure how far the boat sinks into liquids with each density listed below. So for these ones, you're going to need to change the liquid density by dragging this. Make it higher, lower. And then you'll still do how far it sunk down, the volume of the displaced liquid. And then again, mass of the displaced liquid should be the same as the volume of the displaced liquid because the liquid we're displacing is water. Feel like you guys should be able to finish the rest of this on your own. If you have any questions, please email me.